Okay, I think I'm going to get started. So, good morning, everybody, and thank you for coming to this session today. Appreciate it. My name's Rajiv Nagar, and I work on platform technologies within Windows. And today we are going to talk a little bit about our investments in the area of storage. Hopefully this is the beginning of a discussion with many of you. I see a lot of partners in the room, and we've been talking about this for a while. We are now doing it broadly, and we can continue the conversation going forward. The way we're going to do this is I'll go through the slides. We have a few, we think, fairly interesting demos for you. We'll present those, and hopefully we can save the questions for the end of the talk, and then we can have a conversation. But if anything's not clear, we'll try and clarify it. I'm going to be joined by one of my colleagues for one of the demos at the end of the session. This talk is part of a series of talks. There was one that was held this morning by Thomas Fenning, and you will see a lot of talks today and tomorrow that are in and around the area of storage. You will see different perspectives on this. You will see a platform perspective on this, and you will also see a workload perspective on this. And hopefully you can see end-to-end how this stuff can be consumed by our customers. So a little bit more about how this talk is structured and what we are trying to communicate. Broadly speaking, this talk hopefully will be helpful to those of you who integrate storage into your systems, to those of you who build storage infrastructure, and to those of you who provision, consume, or control storage. So those of you who write applications, different types of applications that have to deal with storage. We are going to go through a range of topics over here. From the platform onwards, we're going to talk about how the platforms evolved around certain dimensions: availability, manageability, and utilization. We're going to talk about something fairly interesting, and you will see this as part of a theme, which is delivering cost-effective solutions. And then we are going to talk about maximizing value from existing infrastructure. And hopefully at the end of the talk, you will leave with what's written over there. You will agree with me when we say, we are working with you, our partners, to deliver very differentiated, continuously available, scalable, cost-effective storage solutions to our customers. So over the last couple of days, there was a lot of reimagination going on. I don't know if you saw the keynotes, and there was this talk about Windows reimagined. And a couple of years ago, roughly speaking, we were thinking about how do we approach our investments in storage going forward. And so we spoke to a lot of customers and partners, and a few key themes emerged, especially from our customers. They have very simple requirements. They basically said they want to keep their services running. They don't want to pay a fortune to do it. And they really cannot deal with the complexity of doing it on an ongoing basis. Our customers, in many cases, are your customers. And they basically said very loudly and very clearly that it was becoming unsustainable for them to continue to manage the complexity associated with storage that they have to deploy, and the costs were becoming unsustainable for them. So we heard them, and that drove the basis of our investments in storage. And we believe this is where we've landed. What we want to deliver is a platform in conjunction with you, our partners, that delivers on the availability guarantees or requirements that our customers have and the scale requirements that our customers have, and does that in a very cost-effective manner. You will see me talking about the same themes over and over again in this talk, and you will see those themes repeated in other talks, and they are very simple. It's all about efficiency. It is all about availability. It is about scale. And it's about cost effectiveness. And that captures what we've been working on. And hopefully, in conjunction with you, we can deliver all of this. So in terms of the details, what are we going to talk about today? From a platform perspective, we're going to talk a little bit about our investments in availability and manageability. We are going to talk about an exciting new class of solutions that we can jointly deliver to our customers. We are going to talk about deriving greater value from external storage arrays. And then we are going to talk about maximizing utilization in order to deliver on the efficiency promise that we want to deliver on. And we'll go into detail in each one of these. So let's start by talking about file system availability. There's an interesting trend that's out there, which is the amount of storage and data that the average consumer has today is much more than the average enterprise had in their data center, say, a decade ago. And the average enterprise has a mind-boggling amount of data to deal with. And in all cases, regardless of whether it's the consumer or the enterprise, I have yet to meet anybody who says they like not to have access to their data. Whether it's the photos that you store, or whether it's your mission-critical data, you want to have continuous access to it. The other interesting thing is, and this is a truism, that's the one thing I think you will all agree with, is that things fail. Stuff happens. And the promise we want to give to our customers is regardless of the failures that occur, we want to keep going. Now, some of the failures that occur are subtle failures. Failures that lead to inconsistency in file system metadata that prevents the file system from being able to deliver data back to the consuming application. And we made investments in Checkdisk all along over the years, which you've seen, to speed up any downtime associated with repairing these corruptions. But beginning with Windows 8, you will see a change in our mindset. In the past, we used to have an approach that said either your data is good or your data is not so good and we need to go fix it. And we took your service down while we went and fixed the file system. Now we basically say something different. We say regardless of the state of the system, we will endeavor to keep your service up and running. So even if it's not good, if there are issues, we're just going to keep going and we'll fix it while your service is on. And if we have to take you down for any reason, we will do so for the absolute minimum amount of time required. And there are some exciting investments that we made in this area in CheckDisk, but it's not the old CheckDisk that you knew and did not love. This thing keeps going. Regardless of the state, it basically, at the end of the day, what it translates into for our customers is something simple. They can now confidently deploy large data sets. As all of you know, CheckDisk times are not proportional to the size of your disk or the size of your volume, but they are proportional, have been in the past, to the amount of data stored in them. And if you have bigger volumes, you have more data, and running CheckDisk on that would take you sometimes hours, sometimes days. But now, your downtime is only proportional to the number of errors that we detect, and we detect those errors while your service is up and running. And this results in a dramatic improvement in uptime for our customers. You will see more detail on this in a follow-up talk this afternoon. But I wanted to see this, which is there's a considerable amount of investment, and you should look forward to a very exciting demo, exciting as they can get with CheckDisk, later this afternoon. So please go to that talk, and you will get more details on our approach, our architecture, and the result, which is pretty impressive. Going back to what I said at the beginning, which was we are endeavoring to lower complexity. And by lowering complexity, our objective is to lower cost. You heard this in the keynote, which is it should not take our customers to acquire a PhD in storage, as one of my colleagues very eloquently put it, in order for them to use storage, to get access to their data. And we've invested very significantly in storage management, beginning with Windows 8. The key things to note over here are very simple. 3 things. The set of tasks that our customers want to do that are called common tasks, the bar's just gone up on that. In the past, our customers wanted to do things like partition a disk. Now, they want to do things like pool a set of disks. And that's just par for the course. It's interesting how many enthusiast customers we have who do this at home. And certainly, it's a requirement in the data center. So, the set of tasks that are needed, that are considered common tasks by our customers, the bar's gone up on that. And what we've done is we've invested in delivering a very comprehensive and extensible API that allows applications that consume storage or manage storage to do so with different kinds of storage devices in a uniform manner. We have 2 kinds of interfaces to this API from an applications perspective, WMI-based or PowerShell commandlets available for all of these tasks that are remotable and scriptable. So from an applications perspective, it's uniform. Regardless of the type of storage that's there at the back end, assuming that that storage infrastructure fits in with Windows, they can manage this infrastructure, consume that storage, perform common tasks in a uniform manner. And at the end of the day, what that does is it reduces complexity for our customers, our joint customers, and therefore reduces cost. Now, In order for this magic to happen, we have a corresponding set of interfaces that allow storage systems to fit in with Windows in a seamless manner and be manageable by Windows. And we have embraced SMIS as a standards-based approach to managing these storage subsystems. And we allow other storage vendors to have host-based extensibility through a set of well-defined interfaces should they choose to do so. It looks something like this. There are a set of applications, whether they are Microsoft applications or third-party applications, and they can now consume and control storage through this one API that will be continued to be extended. And below, you see three different kinds of storage systems, one of which we will talk about in more detail today. An SMIS compliant storage subsystem managed through SMIS through this one uniform interface. A storage subsystem that basically has a host-based has some host-based software provided by the vendor. And then through the same interface, you can manage storage spaces, which I will talk about a little bit more very shortly. And if we dive a little deeper into this, you see the architecture in a little bit more detail. And you will notice that our tools, the ones that we are shipping in Windows 8, leverage the same API. For example, the File Server Administration Console, which is a single pane of glass that allows you to manage the file server role. And you notice that on the lower edge, there are different ways by which a storage vendor can enable their storage subsystems to be managed through this one interface. And again, the end benefit to our joint customer base is very simple. Those applications that are being developed, they can now consume controlled storage very easily. And our poor customers do not have to hire those guys with a PhD in storage in order to leverage all of the wonderful hardware that you, our partners, are delivering. And I spoke about PowerShell commandlets. I spoke about the ease of management. And here is an example of that. 6 commands that essentially take our customer from being able to do advanced things like pooling a bunch of disks to carving out a virtual disk to assigning attributes to that virtual disk. For example, saying that virtual disk should be thinly provisioned, to partitioning it, formatting it, and making it available for the application, in this case SQL, to consume. 6 commands. Remotable, scriptable. And that's the ease with which our customers will be able to manage your storage infrastructure as you fit into Windows. I am not going to subject you to the pain of walking through each of those commands, but this thing works. All right. We're going to talk about something different, interesting, that is being delivered with Windows, and we fondly call it storage spaces. And you saw a demo of that in Satya's keynote yesterday. So what is this? Going back to what I said at the beginning of the talk, our customers want availability, they want scale, they want efficiency, and they want cost-effective storage. And Storage Spaces enables our customers to get cost-effective, available, scalable storage very easily. There are two new platform abstractions that are now part of Windows. Simple concepts that are now inherently in Windows. The first concept is the concept of a pool, a storage pool. Our customers can now just take a bunch of disks, connect them to Windows, and aggregate them into a single unit called a pool, and then administer this pool easily using the same set of interfaces that we looked at a moment ago. And then there is another powerful abstraction deeply embedded in Windows now that's called a storage space. It's nothing else but a virtual disk with attributes associated with it. Things like how available do you want it to be? Things like, do you want it to be thinly provisioned or not? So a space is just a virtual disk, and the entire Windows stack now builds on top of that. What this enables us to do collectively is deliver some very powerful solutions to our joint customer base at very interesting price points. And because these are manageable through the same set of interfaces that we looked at before, PowerShell, WMI, the same storage management API. In fact, the script that I showed you runs against storage spaces. This delivers on the promise of operational simplicity to our customer base. Conceptually, it looks something like this. You basically take a bunch of disks, literally, and connect them to Windows. Our design point is SAS. It's a reasonably fast interconnect. SATA works, SAS works better. And then our customers can now aggregate them into what we call pools. And we'll talk a little bit more about what pools enable our customers to do. And then our customers can very simply carve out these virtual disks called spaces. In this particular case, there are 3 storage pools and a few spaces. And then all of Windows just integrates with this set of platform abstractions. So all of these other boxes that you see, those are the new interesting capabilities or enhanced capabilities being delivered as part of the Windows platform. And then our customers could choose to run either physical or virtualized workloads directly on this stack, or they can deploy highly available, continuously available file servers and then run the workloads remotely and access their data through the file protocol. Their choice. The deployment model physically literally looks something like this. But don't take it literally, as in the number of boxes, the disks that are shown over there. We can have a conversation about that. But our customers can basically now take those disks, connect them by SATA or SAS to one single system, or if they want continuous availability, they can take the same set of disks, connect them through shared SAS, which is now the storage fabric, if you will, to multiple nodes that are clustered. And then in either case, once they've connected them physically like this, they can carve out pools, they can cluster the pools, and then they can expose them to the application either through the file protocol or directly natively running on that machine, whether physically or virtually within Hyper-V. Now think about what this does to our customer base. It basically says, hey, here is an interesting class of storage solutions at a very interesting price point that's scalable and highly available. And at the end of the day, it's all about giving our customers that promise of you will get more value from our collective solutions that we deliver on Windows 8. There's a bunch of capabilities that storage spaces deliver on, and they're listed here. And I'm not going to talk about them in detail right now. There is a follow-on talk this afternoon where my colleague will talk about them in more depth. But the capabilities are along the lines of what you would expect in a cloud-optimized OS, where our customers want availability, scalability, efficiency, and simplicity of administration. But here's what I am going to do, or at least I'll try to do. I'm going to try and show you a demo that gives you a sense of the scalability and performance characteristics in a controlled environment that you could get with Spaces. So I'm going to switch to this. I have my fingers crossed. And here we go. Okay, what do we have here? We have Iometer running, or we will run Iometer, which is a standard tool that kind of simulates the expectations of a storage subsystem for either transactional, high transactional workloads, or workloads that have a large bandwidth throughput requirements. Let's see what we get when we run this. So in this particular case, I have a machine back in Redmond. This is live. And I have 16 worker threads set up that are going to send I/O requests down to essentially simple storage, a bunch of disks. In this case, they're SSDs. 40 of them. And that environment looks something like this. This is live in Redmond right now. Bunch of SSDs, Intel, connected to a Dell server via SAS. That's it. Nothing special about this. And we have a simple SAS HBA from LSI. Let's see what we get. In this case, you will see that it's configured. These worker threads are going to talk to this storage space labeled Microsoft Storage Space 0. Each worker thread is going to send 32 requests outstanding at any given point in time, 4K requests. And here we go. We are going to start it and see what happens. Now I have my fingers really tightly crossed. It would help if I press start. Let's go. I was instructed not to breathe. I'm going to hold my breath. This thing's going to run for 10 seconds. And we will see 10 seconds, about 900,000 IOPS. Read IOPS. Please remember this is a very controlled environment. Your mileage may vary. And we are still working on this. These are pre-beta bits. But going back to what I was talking about, the promise of simple scale. This is one dimension of scale. Simple Intel SSDs. I won't talk about the cost of the solution because it's incredibly cheap. No, it is really incredibly cheap. Take my word for it. You can go look them up. The cost of those disks, not bad. All right, so this was a transactionally intensive workload. Let's see if we can do something different. What if we had a workload that basically needed throughput, needed high bandwidth, that didn't need IOPS? Okay, so let's look at that workload. In this particular case, I have one worker thread that's going to send very large requests down to the storage space because it cares about throughput. And what we are going to do is now look at megabytes per second, a different metric, using the same tool, Iometer, the same setup that I showed you, and this is running live. We simulated the other workload for 10 seconds. We are switching to this particular workload, and off we go. I need to remember to press start again. 3.2 gigabytes a second. Throughput. The same set of industry standard, quote unquote, commodity components, running spaces, delivering 3.2 gigabytes a second on this Dell server. Different kind of workload. And here we go. So hopefully this gave you a sense of scale simply delivered to our joint customer base. And the kinds of solutions and the kinds of workloads that you could deploy potentially on this particular technology. Okay, so my luck's holding. We'll see how long it holds. This was the demo configuration. I have three very good, very kind-hearted folks in Redmond right now standing by, and they'll be happy to know that this thing actually held together. So big shout out to them. All right, so let's talk about something different now with spaces. Let's do another demo. These are, again, live bits. So we'll see how it all works, or doesn't. This is a configuration in Redmond right now. And if you look at it, it's very simple. We have basically two Supermicro servers. You can have more. In this case, we just pick two. Easy to set up. Connected to one Supermicro JBOD that has a bunch of disks in it. Again, you can go look at the price point of this system, where it's fairly competitive. But what we've done over here is interesting. We've basically taken a bunch of disks, physical disks that are in that Supermicro box, and we've created this thing called a pool that I spoke about before, which is now within the OS. So we put a bunch of disks into a pool. It's a simple command, pool them. But then we've gone a step further. We've said this pool should be accessible to both the nodes at the same time. So it's a clustered pool. Further, we've then said we are going to carve out two spaces or virtual disks from this pool. And we are going to assign these spaces one space to one virtual machine and another space to a second virtual machine. This is a very common deployment topology in the real world. Two VMs running. You'll typically have more. As you notice, Windows Server 8 supports a lot of a great scale with VMs. But in this case, we just simplified it, two VMs running. Each VM has a virtual disk or a space associated with it. These spaces are carved out of this clustered pool, and the pool is made up of those physical disks. And we're going to do something very simple. We're basically going to say VM1 running on server 1, VM2 running on server 2. But wait, there's more. VM1 and VM2 are themselves located on a third virtual disk, which is a space. So now we have three spaces, three virtual disks. Both those VMs are running from the same space. And there's more. The same space is being concurrently accessed by both nodes. Both nodes are looking at the same space, and one node is running a VM off of that, the other node is running another VM off of that, and we integrate with cluster shared volumes to make this happen. So the space at the bottom is the shared space, and the two blue disks, virtual disks that you see, are dedicated. Each VM has their own. They want their own disk, virtual disk. And we're going to do something very simple. We are basically going to make the VMs move. In case you missed that, it took a lot of work, that animation, so I have to do it twice. We're going to make the VMs move. That's all we're going to do. Okay? Let's see how far we get in this particular case. I'm going to switch back. I'm connecting to Redmond right now, and I'm going to show you what I have. This is one of the nodes. This particular node, we call it demo node 2. That was one of those servers that you saw over there. And this particular node, we call it demo node 3. We tried to set it up a few times. One kind of fell by the wayside, so we have 2 and 3. Okay, but we are good so far. Here's the interesting thing. On both these physical machines, you can see that we have, in this particular case, 3 pools created. It's a little difficult to see, but if you look at that box over there, it's a PowerShell window, and you can see that there are 3 pools in this case that we decided to create. Our customers can create more. A pool can be assigned, say, to a finance department, right? Think about that. It's just a unit of administration. In this case, we decided to create 3. All 3 pools are visible here on demo node 3, and the same pools are visible here on demo node 2 because they are clustered pools, so now both nodes can see the same set of pools. But there's more. I told you that one of the virtual machines is running on demo node 2. The other virtual machine is running on demo node 3. Both these virtual machines have a dedicated space with them. So in this case, this is the space for finance. Somebody decided to get creative and said there's a finance workload running, and we've given a space to this particular workload running within a virtual machine. That's the space you see over here. And if I go back to the other node, bear with me here, it'll make sense. On this other node, you see a space for VHD store running. Somebody decided to call the other workload VHD store. Okay, so now we have 2 virtual machines on these 2 different nodes. and we have to move them, or at least give it a shot. So I'm going to go into the Cluster Manager utility. And if you look over here at the top, it says there are two VMs running, the Finance VM and the VHD Store VM. The Finance VM is running on Demo 2. The VHD Store VM is running on Demo 3. That is why you saw the space for the Finance VM on Demo 2, and you saw the space for the VHD Store on Demo 3. I am going to click on this. I'm going to say Move. I'm going to say Migrate quickly. I'm going to select a node, and I'm going to say Move it to the other node. So here, one's off and running, and you can see it. Watch quickly. It's going to go by really fast. At the same time, I'm going to take the other VM, and I'm going to move it back to this node. And off they go. The two VMs are now moving to the two different nodes. It's quick migration. But the interesting things, and one VM's up and running. And if you notice, the Finance VM now says that the owner node is Demo 3. It just moved to the other node. The second VM has moved to this particular node, Demo 2. And if I go back here, I will see that on this node now, I have space for VHD Store. The space moved. If I go to the other node, I see space for Finance. So all we did was very, very simple. Simple in concept. We basically did this. We were here. We had the spaces on two different nodes, and we just moved them. That was it. But what this tells you is, when our customers choose to deploy this interesting solution, they can now deploy multiple nodes in a continuously available manner connected to this shared SAS JBOD from Supermicro, and they can move VMs around, and the spaces, these virtual entities, just move between, they just appear on the node where the VM's running. And also, this is completely integrated with a clustering solution and a cluster shared volume solution, where our customers can now directly access the same space from multiple nodes for high performance. That was it. Okay, moving on. Continuing on the theme of getting more value out of their investment for our customers, we have a very interesting technology called offloaded data transfer that we've co-developed with a few of our partners. Notably, one of them is right here, Dell EcoLogic. And it's pretty interesting. And the concept is very simple. Basically, the concept is, instead, sometimes, for many different reasons, we just need to move data around. Now, we might choose to do that. For example, a tangible scenario is if you want to deploy a VHD, or you want to take a movie and move it, a large amount of data. But in order to move this data, what do we do today? We suck the data into the host from the storage device, and then we move it, and then we put it back again. We're not processing the data. We're just taking it in and spitting it back out. And that is not leveraging the intelligence in the external storage array, which are very powerful systems. So we basically work together to come up with this interesting solution called offloaded data transfer. And instead now of sucking the data in, we go to this storage, external storage array, and we say, can you please give us a representation of the data? Something that says, here is what your data is, but they don't give us all the data. They just give us a token. And then we can move that token around, all around the world, should we choose to. Architecturally, that's possible. And then at the other end, we take that token and we give it to this external storage array, which is a very intelligent system, and we say, here's the token, can you please make my data appear? And these external storage arrays work together, move data, and make that data appear at the target end. Very simple, conceptually. The power of this is exposed all the way to the application. In other words, if you write applications that consume storage, instead of basically reading the entire data set, you can now issue this request that says, can you please go get me a token? And if the storage array gives you a token, you can now take this token and use your own protocol and your own transport mechanism across instances of your own application. And you can say, hey, here's a token, I'm going to send it to my peer application someplace else. And the receiver gets the token, and through this API sends it down to the system. It goes all the way to the storage array, and the storage array or arrays talk to each other and make the data appear. So it's a pretty powerful mechanism exposed all the way to the application, and we've gone ahead and we've completely integrated it with the operating system. The benefits of these are phenomenal. Instead of consuming CPU resources, instead of consuming networking resources on the hosts, we just offload it to this external storage array, which transfers data in the most optimal manner it can. This thing crosses machine boundaries, and if the storage array supports it, it can cross storage array boundaries. So there's no limit. You can do this halfway around the world if your storage arrays can talk to each other. So you can take data here, running on a machine here, send it to an application running on a machine, say, in Redmond. And that application can issue it to the storage array in Redmond, and if the storage array supports it, they will talk to each other and they'll just move data. So let's see if we can make this happen and see what the benefits are and how tightly integrated it is with the rest of the system. Here's a sense of the demo that I'm going to give you. On the left-hand side is how things have worked till today when this capability is not turned on or if the storage array does not support it. And I'm going to show this to you. I have my laptop here, and in room 2120, in building 10, 3 offices away from mine, are those two computers, Supermicro computers, which are basically sharing through the file sharing protocol, through SMB. They're sharing out directories. So there's a machine that's acting like a file share, that Supermicro box. It's basically acting like a file server, and it's sharing out a folder. And the other Supermicro box is sharing out a folder. So these are 2 file servers in Redmond, in that room right now. And I'm going to show you what happens when I do a non-offloaded transfer. This is what happens. I'm going to suck the data in all the way here to my laptop. They're both, by the way, talking to the same storage device at the back through these 2 different file servers connected to the same storage device. I'm going to suck the data all the way here, and then I'm going to push it back there, and it's going to go to the same storage device at the back. Like, duh, that's not good. And then, this is what we are going to do with the offloaded transfer. Did you see that? We are going to just copy a file, and the storage subsystem at the back, which is an Equalogic storage array, is going to do its magic, and the data is just going to move. Okay? So let's see if this works. I'm going to switch back to my system. Okay. Here we go. So right here I have the source, which has a bunch of VHDs. I'm trying to give you a sense of how a typical deployment scenario. Customers deploy VHDs. By deploying, what do? They take a gold image of a VHD and they push it someplace else and they start running a VM, right? Okay. So there's a bunch of VHDs over here in a library, and this destination is a share on an EqualLogic external storage array, a smart array that supports this token-based mechanism. So watch carefully what happens. I'm going to show you what's happening in terms of network consumption. I'm going to take this VHD from one file server, which is a physical machine, drag and drop it to another file server, which is a different physical machine connected to the same EqualLogic storage array. I'll say yes, and it's copying, and you can see the speed, 179 megabytes. Let's, for the fun of it, do 2, and you can see the speed right here, if I can pull it up. Okay, don't want to lose it. There. So these copies are happening. And the interesting thing is what you cannot see. Here are my 2 connections, network connections on this laptop. Remember, I'm copying from my laptop across 2 physical machines in Redmond, and they are copying at 250 plus megabytes per second. 2 different VHDs, 2 different machines in Redmond in that room, 250 plus megabytes a second. And on my laptop, the networking consumption, nada, 0. There you go. Done. The second one, the speed's going up because it's free now. Done. That was the offloaded data transfer. Feel free to applaud. And we are going to do the same thing with the storage device that's not as smart. So I'm going to take this VHD, I'm going to drag and drop it to this storage device that's not supporting this particular capability. Off we go. So let's see, how many hours do we have over here? Maybe tomorrow it should be done. What it's actually doing is it's actually trying to suck in data all the way to my laptop. It's still trying to figure out how long it'll take. It hasn't begun. It's working really hard. And remember, in this case, the computer, my laptop's doing nothing with the data. It's basically sucking in data. Just to put it, same room, 2 different machines in the same room, and now I'm sucking the data all the way down to Anaheim. So, I think I will spare you the agony of sitting here for the next couple of days while this copy finishes. And it's going to take a horrendous amount of time to do this. So there you go. That's the demo. Very simple. And this is all that happened. In the bad case, this is what's happening. In the offloaded data transfer case, that's what's happening right now in Redmond. There you go. Okay. Oh, I really should show you this. I'm going to switch back. It figured out it'll take about 17 hours to do this copy now. That's it. So there, it finally did figure it out. About 17 hours. Speed is about 84 kilobytes a second. All right, moving on. This is the power of exposing this API. By the way, you saw that it was very tightly integrated into the Windows shell. And we also have exposed this through these APIs. So here is an API that applications can leverage. If you write applications, you can essentially read the token. It comes all the way from the storage array to you. And then you can send a write down through a write token command, and then the storage array will perform its magic. And that's all the code you need to write. Well, maybe a few error checks and things like that, but you get the idea. Okay, so once again, this gives our joint customers more value from their storage investments and leverages the power of the external storage array. Continuing on the infrastructural enhancements we made, we've done deep enhancements for working better with thinly provisioned disks. So we now have a standardized way of consuming notifications when you're running out of capacity, and we can notify the administrator or an application, and they can then back up a truck and add disks as needed. We have a storage optimizer that works in the box, that runs when the system's idle, when it can. It tries to coalesce data physically, and then issue trim commands to the storage array, which is supported by Spaces as well, and by external storage arrays. And the storage array can now free up physical space because the data is all packed well together. We've invested substantially, I'm going to take questions as soon as we finish, in data deduplication. And this is, again, on the theme of increased efficiency. We basically get some very interesting savings for different kinds of data sets. And that's what we've optimized for. We do the deduplication at the chunk level within a volume. And we ensure that resiliency is preserved. In other words, we guarantee that your data will be available to you despite the fact that we've now deduplicated it. We work very hard for that. And we've also worked very hard not to impact the server. So to do it when the system is capable of doing this and not when it's active. This data deduplication is also integrated with our branch caching for optimal data transfer. And so that gives great efficiency savings over high latency, low bandwidth connections. And this is all manageable, again, through the server manager, through PowerShell, and through WMI. And you can continue using your data just like you do over the file server or natively, doing native access to that data. We have an interesting demo over here. I'm going to invite Amit to come and give that demo. I know we are running out of time, so we're going to take 5 more minutes. See, Amit. Thank you. We're going to switch to this machine.
Yeah.
And minimize all of this. This thing's still going. It's trying to cancel now. It's working hard. Demo 2?
3.
This is 3. Okay, off you go.
Thanks, Ravi.
Yeah.
Hi, everyone. How many people were there yesterday at the Windows Server 8 session and saw the dedupe demo? So maybe about half. So what I'd like to do is talk very briefly about what we can do with deduplication, where basically we made a major investment in state-of-the-art dedupe in Windows Server 8. And this is something, I showed it yesterday for VHDs, we talk about it a lot, but it's actually something that is general, that's file format agnostic. It works for all data types. It works just as well for Office documents, it works for media, it works for any kind of data type, and it's able to very, very effectively identify and remove duplication within the data. What I'm going to show here today is kind of a slightly different take on what you saw yesterday. Again, we have a Windows 8 server, and we're using that as a VHD store. So we have a volume here where we're storing large numbers of VHDs. And if for those who were there yesterday, they remember that what we showed is basically, we showed that we have a total amount of data that kind of sums up to about over 10 terabytes. And we were storing that only in 400 gigabytes of space, sitting on the same volume. So that's just data sitting in 4% of its size. And this is, again, the same thing here that we have on one of those machines that Rajiv showed in Redmond. Now, what is interesting I want to show about today is actually I'm going to show how this works well with storage spaces that Rajiv walked through. So this very same volume that I have over here is actually provisioned over a storage space. What you can see on this in Server Manager by looking at the machine pools and on that particular volume is that over here I have 3 physical disks, and I'm basically combining these and I'm using them into a space. And what I'm doing is I'm thin provisioning. So I'm taking about 6 terabytes of data, and I'm making that look like I have 10 terabytes of space. And essentially what I'm doing is I'm actually really putting 10 terabytes of data in that space, but with dedupe I'm actually shrinking it. I'm not using all of it. I'm not even using a single terabyte. So in this case, what I'm using deduplication to do is not necessarily to be able to put more data into the volume or to be able to just take some space and use it somewhere else. I'm actually using deduplication to make room for more redundancy, for higher availability. So this kind of raises, I'm able to use it to raise my SLA over the data. And that's kind of the beauty of being able to use these two technologies together. So essentially, one technology kind of gives you all the space with deduplication, and then with having something like spaces and provisioning underneath, then you decide what you want to do with that space that you just freed up. You want to put more data? Great. You want to use it to create another volume and do it, use it in a different pool? Great. You want to actually improve your SLA and just have more redundancy and just have more copies of that? Great, you can do that too. And all of that is leveraged, in not just in how you access your data, but also how we protect, how we're able to recover in case issues happen with your data. We have good integration at that level. So I think with that, we're running just out of time, which sort of hopefully gives us time for questions.
Yeah. We are going to switch to... I will let you read this, but since we've run out of time, but as you can see, there are significant new opportunities now available to us collectively to deliver some very interesting solutions to our joint customer base. If you're writing applications, you can consume these technologies very easily, whether they're management applications or other server applications. We'd love to work with you on these. A big shout out to some of the partners who are working with us on these solutions right now. And I actually demoed the Dell EqualLogic solution to you. Spaces was running on a Supermicro system. All of these other partners are working very hard with us. NetApp, HP, IBM, Fujitsu. So thank you. And we'd love to continue working with all of you on these. There are other talks today that you should go to that continue building up on what we've spoken about over here. And are very interesting. They talk about continuous availability and scale, and how that's done, leveraging the infrastructure that we referred to today. And with that, we are done. Please fill out your feedback forms. And if you have any questions, we're going to hang around here for a few minutes while the other speakers are going to set up. So thank you.